Try this one. So, any ideas?
Integral test.
Let's see. Could you do integral? No, not integral. What's the first one you should always try?
Nth term.
Yep. So let's try it. What happens when I do the limit as n approaches infinity? What do I get?
Good. Sine approach is 0.
And what is n?
Sine 0. So
And what is n approach?
infinity.
Do you recognize that at all?
Yeah.
It's one of your indeterminate forms. And whenever you get one of these forms that looks like this, if it isn't 0 over 0 or infinity over infinity, you can't do L'Hopital's rule. So we got to try to get this to look like that. All right? So let's go ahead and do it. What happens if we do that? Or do you know how to get there from this? Can we get it to look like this form? I think you and I did a problem like this, but it was sequence. We approached this problem when we were doing sequences. Do you remember?
Yeah, I remember now.
Okay.
You divided the
divide the n, right?
you divide the you divide the whole thing.
And what does it become when I flip it to the bottom?
Comes shit. Can't remember Dessa.
It's okay. Don't be using my government name, please. It flips. Okay. Remember, when you divide by something, you flip it and multiply, right? So if I had this to get back up to here, what would I do? Well, I would flip this bottom term and I'd multiply by n. That's what I have right here. So what I can do is I can go backward with it and unflip it, if you will, and get it into that form and put it in the denominator. Does that make sense?
Oh, okay. Yeah.
Okay. So take the reciprocal of the least complicated one whenever you have this term and put it in the denominator. Now, at this point, you do get 0 of 0, and your first gut response might be to do L'Hopital's rule. But you should remember a Calc 1 identity. Do you remember your identity? Oops, no, it's 0 over 0, sorry. There's an identity with limits to do with sine.
No, I don't remember it.
It's okay. It says the limit as whatever approaches 0 of sine whatever over whatever or whatever over sine whatever equals 1. As long as those boxes are the same thing and approaching 0. Do we fit that criteria right now?
Yeah.
Right? Because if I plug in infinity here, what happens? That goes to 0. And that goes to 0. Right? And they are the same thing, so what does this whole limit equal?
Like
we got the same.
We can just plug it into the other one, into how you have it for the identity.
We can. We can do a substitution if you want to. If you don't like it the way it sits, you could easily say let t equal.
Yeah. It's already in that form.
Yeah, but what I'm saying is, like, if you want to go ahead and do the substitution, let t equal 1 over n, that's fine. all you would have to do is as x approaches, or I'm sorry, as n approaches infinity, what happens to t?
Goes to infinity.
As n approaches infinity right here, what happens to t,
Oh,
which is
and I mean, oh, I said T. 0.
0, right? So then you could
Yeah.
substitute everywhere you see 1 over n to get this new limit of t approaching 0 of sine t over t, and now you literally have that identity. And that will equal 1.
1.
Do you see that? What good does that
Yeah.
do us? What good does that do us to get a 1? What's the big picture?
That it's that means it's divergent
Divergent by what?
by the n. That's still n turn test.
It is.
Divergent test.
Yeah, either or. Now, I'm missing a vital piece. I said that it diverges, and I said that what test, but I didn't say why. Make sure you just say why. You have to say not equal to 0, therefore divergent by nth term test. Okay? Any questions?
So that identity, we just need to know that.
Yeah, that was just
Memorize it.
yeah, that's a trick they might just pull out of, their
Yeah.
butts just to separate, the people that are really studying and the ones that are kind of studying. All right, you
All
ready
right.
for the next one? Do you have this written down?
Yeah.
Are you writing them down? Christian, you're not writing these down, are you?
I am.